This lesson is for Chapter 3, Section 1, Quadratic Functions and Models. So if you guys would all please get your textbooks open and your notebooks open, we'll get this lesson started. So a couple of vocab words for us here. If you're looking on page 242 with me, we have polynomial functions and we also have the word degree. Now, most of these I think are going to sound familiar to you. A polynomial function is a function that has many terms in it. Generally, they are always written in descending order. So your highest powered term is in the lead, and then it goes down in descending order from there. Degree then refers to the highest exponent in a polynomial function. Okay, so always begin the writing of your function with the highest degree term. Sorry, my pens aren't aligned here. I'm going to take a break for a sec. Hold with me. All right, let's try this arrow button again. There we go. So for example, if we have f of x is equal to 5, there is no exponent in this one. It would be similar to having, if we had 5x to the 0 power. Remember, anything to the 0 power is 1. So I suppose technically there is a power in there. It's just going to be that 0 power, and that's why our degree is 0 for that function. F of x equals 3x. The power on that variable is a 1, so it has a degree of 1. The third one up there, f of x equals 2x squared minus x plus 4. That's going to have a degree of 2. Has a power of 2 in it. A polygon with a degree of 2 is a quadratic function. We've been working quite a bit with these as of late, so you'll recognize that, I feel. The graph ends up being a parabola. Parabolas are going to be symmetrical. All right, so all parabolas have what's called an axis of symmetry, which is just simply a line that's going to cut it in reflective halves. Okay, so you guys have studied symmetry in the past. That word, I think, is familiar to you as well. This slide talks about and kind of sums up a little bit of what we were talking about with our transformations back in Chapter 2. A parabola with a positive coefficient in front of x squared is going to open up. If you have a negative coefficient in front of x squared, it's going to open down. And if you think back to what showed a reflection over the x-axis, it was having something like a negative x squared or a negative 4x squared or so on. So we've already technically looked at that. And it's that reflection then that makes that parabola open down. It flips it over. Okay, so those kinds of things are tied between the two chapters. We've seen these, a few of these things before. So if we were going to look at this and do a little bit of sketching, let's sketch a couple of them. My top function is 1/4 x squared. Now notice that the 1/4 is positive. So in looking at that, I know it hasn't been reflected. It's still going to be an opening up parabola. Pick a few values. Okay, if we put a 0 in, 0 times 1/4 is 0. If I put a 2 in, 2 squared is 4. 1/4 times 4 is a 1. If I put a negative 2 in, I'm going to get that as well. Then I'm going to jump to a 4, and I'm just picking, whoops, that was kind of crazy. I'm picking values that I know are going to kind of multiply by a 1/4 easy. That's why I skipped 3 and I skipped 1. Okay, you could use them, but you're going to get some fractions. So if I plugged in a 4, 4 squared is 16. 1/4 times 16 is 4. Negative 4 would result in the same. So then I could go over here and do my graphing. 0, 0. 2, 1, negative 2, 1, 4, 4, negative 4, 4. Now again, there's another piece in this function and in the graphing of it that you should recognize from our last chapter. And it was this multiplier out front. Do you remember how having that value less than 1 out front as a multiplier ended up being a vertical shrink? Notice how this was that general shape of a parabola, but it's fatter. Okay, so that vertical shift is there. We can see it in our graph. All of that's matching up, and we can feel pretty good about that. Next one. Okay, looking at this one, notice there is a negative lead coefficient. This parabola is going to open down. It's going to reflect over the x-axis. So knowing that, excuse me, I already have kind of a visual in my head then how the shape's going to look on my graph. Pick a few values for this one. If I plug in a 0, I'm going to get out a 0. if I plug in, and I'm going to keep my numbers as small as I can here, they're going to grow fast. If I put in a 1, 1 squared times negative 4 is negative 4. A negative 1 squared is also 1 times negative 4 will give me a negative 4. Now even if I go to 2, okay, 2 squared is 4 times negative 4 is negative 16. So I'm already falling off my graph paper that I have to draw my picture on, but we'll still get an idea of what this picture is going to look like, or what this graph is going to look like. All right, so this one I'm doing in blue over here. So 0, 0, 1, negative 4, negative 1, negative 4, 2 and negative 16. Okay, negative 16 is going to be way down here. So you can see this stretch going on. It's going to be tall and skinny, okay? And you know that that constant out in front is what does that vertical stretch, again, based on last chapter in section 5. All right, moving on. We're going to be taking a look at something called the standard form of a parabola. Now, an equation or a parabola function that's in this form is going to be very easy to graph because it identifies the vertex for us. The vertex, of course, of that parabola is that maximum or that minimum, that starting point of your curve. In this standard form, you see an H and you see a K. Now, we played with H's and K's back earlier in the year too with centers of circles. H and K represent the vertex of a parabola. X equal to H, okay, if we were to write that equation, that's going to mark the axis of symmetry. Remember that the number A, okay, look up in there in that standard form. Do you see where A is placed, where it's multiplied to that parenthesis piece? A would represent the vertical stretch or shrink if, in fact, there was a number sitting there. Okay, so you very well could end up with a constant in that position, fraction or integer. All right, let's play around with this a little bit. To find the standard form, okay, to come up with that x minus h squared part, you may very well need to do a completing of the square process. All right, that again is something that we have already practiced and studied back in chapter 1. All right, so more stuff coming back up and being reused in chapter 3 here. So let's take a look at this one. Write the quadratic in standard form and then sketch it. Okay, so I definitely do not see my standard form of a times x minus h squared plus k. Okay, but I want to get it in that form. All right, so here's what you're going to do. Okay, do you remember back when we completed the square where we kind of shoved the constant away to the side? Okay, back then we put it to the other side of the equation. So this is going to be a little bit of a change. We're just going to shove it off to the right. Also, when we completed the square, we did not want to have a lead coefficient. We wanted a 1 as our coefficient of our x squared. So the first two things I'm going to do here, I'm going to take this part, and I'm going to separate it from my 4. And I'm going to get that 3 off of there. Okay, and I'm just going to leave a space here. And then I'm just going to shove my plus 4 just to the back a bit. Okay? Now, taking a look at that inside parenthesis part, I want to complete my square. I want to finish the process of completing the square. Remember that process is taking that x coefficient, cutting it in half, and then squaring it. So if I put a positive 1 inside this parenthesis, I would create a polynomial, a trinomial that's going to factor into one of those doubles, into that squared factor kind of thing. Now, by putting a 1 inside that parenthesis, you need to determine, all right, what value did I just put into my function? Okay, well, by putting a 1 inside that parenthesis with a 3 out front, do you see how it's actually worth 3? Okay, because if we were to distribute that 3 back in there, that back term would be a value of 3. So to balance my equation, I need to, if I'm going to put 3 in, I need to take 3 out. Okay, so just take a look at that for a couple of seconds. If you need to pause this for a moment and just study it, please do. Obviously, you can come in and ask more questions about that if I just lost you. but I ended up with that plus 1 inside so that I could factor the way I want. That technically was a value of 3. I don't want to add 3 to my equation. That would offset it. I need to balance that out. So behind, I did the minus 3. Okay, so factoring my polynomial now. This is going to be an x minus 1, x minus 1. So I have two x minus 1s if I were to factor that piece. My 4 and negative 3 come together and form 1. Okay, so there's my new f of x rewritten. I can see my vertex point. H is sitting right here. K is sitting right here. So my vertex is 1, 1. Okay, now I can come over and I can do some graphing. I've got the point 1, 1 to mark my vertex. And now you can just generate a table of values if you'd like. So we already know 1, 1 is in there. Parabolas are symmetrical. So pick values that surround your first x value. So if I go left of 1, I'm at 0, right of 1, I'm 2. Those 2 points should mirror each other. So if you remember all of that graphing of parabolas back from Algebra 2, this is what you did to come up with more points to graph. If we plug 0 into this equation, we're going to come up with 4. Likewise, if we put a 2 in, if you put 2 in for x squared in the x spots in your function, you're going to get a 4 there as well. All right, so 2, 4 and 0, 4 are a couple more points, and we can get the general gist of how our parabola curve is going to go. Okay? All right, so let's do it again. It says sketch the graph, identify the vertex and the x-intercepts. All right, so there's a little bit more now. Remember what an x-intercept is. X-intercept is where the graph crosses the x-axis. X-intercept. Now think about your y value if you are crossing your x-axis. All of your y values is 0 here. Okay, we've worked with all that intercept stuff and finding zeros of our graph. Here we go working with it again. All right, so first I want to identify my vertex. I'm going to rewrite this equation in vertex form. So right now we have f of x is equal to x squared minus 4x plus 3. Okay, I right now the way it is, if I factored it, I would not have one of those squared factors, so I'm going to complete the square. Nicely this time there is no coefficient in front of x squared, so I don't have to do anything about that, but I am going to shove my 3 to the side. Now half of negative 4 is negative 2. Squaring my negative 2, I have a positive 4. So I'm going to add 4 to this front chunk. Now in adding 4 to my equation, somewhere over there I also need to deduct 4. Oop, sorry, that was a plus 3 I shoved off to the side. So I need to deduct 4 back here as well. Do you see how I put in 4, I took out 4, I actually added 0 to my equation. That's safe. Factoring the front. It's an x minus 2, x minus 2. X minus 2 squared is another way to write that. And then 3 and negative 4 give me a negative 1. Here's your h. Here's your k. Your vertex is 2, negative 1. Okay. Now, 2, negative 1 is where my graph can start. So here's my vertex over here on the picture. I need to figure out where my intercepts are yet. So I need to find out where is my function equal to 0. So come back to x squared minus 4x plus 3. Okay, I want 0 to be equal to that. Well, when I look at this, to me, this is factorable. If I have minus 3 and minus 1 in there, I have my polynomial factored. There's a 0, and there's a 0. Whoops. There's a 0. So the point 3, 0 is an intercept, and the point 10 is an intercept. And if we did a table of values, you'd end up getting them probably as well if you picked points to the left and right of your vertex to plug into and find more values to graph. Okay? You may still want to do a table with a couple more values, but I think you can see how your curve for your parabola is going to go. All right, so writing equations of parabolas. Remember that the standard form is f of x equals a times x minus h squared plus k, where h and k is that vertex. Recall, and we've been working with this already, f of x means the same as y. X is just x. You remember how, like when we're trying to come up with a linear function, you know, if you're given 2 points, you've got to find your slope, use one of them for x and y, plug in what you have, find the thing that you don't. This is the same kind of concept. So if we need to write an equation where they're handing us a vertex, we can use a point on our graph and that vertex to plug in 4 out of our 5 missing things. Okay, this is a y, this is x. Okay, so if they give you a point, those 2 numbers would go in those 2 spots. Here's part of my vertex and here's the other part. So if they hand you the vertex, you can put h and k into their spots. The only variable that you'd be missing is a. And we'd be able to easily solve for that if that was the only variable left. So that's what we're going to take a look at here next. So write a standard form equation for the parabola with a vertex of negative 411 and that passes through the point negative 615. So if negative 615 sits on your curve, that has to be an xy point that would be in a table of values. This is my vertex. So hk are negative 4 and 11. All right, so let's go to our standard form here. Remembering that f of x is y, plug your y value in for f of x. That's a 15 this time. They do not give us a. My x value is negative 6. H is a negative 4, so minus a minus h is going to be plus 4. And k is 11. Okay, so sit back and look at that. See if you can follow where those 4 numbers went in y. And now we just start to solve for a. Square your negative 2 now. Get rid of the 11. And get rid of your 4. So this time a ended up being 1. Well, 1 times a parenthesis doesn't show up. You can write it there if you want, and I will at first here so that you can just see where that number would go if it were anything else. But here's your function in standard form. F of x is equal to a times x minus h, remember minus a minus number is plus, squared plus k, plus 11. Okay? Or, since a was a 1, you could just leave it out. Doesn't change anything. Those two are the same. Okay, standard form of the equation. Now here's another thing to bring back and remember. There's another way to find a vertex other than rewriting an equation in standard form. If the vertex isn't given, you can find part of it by using negative b over 2a. Okay, that'll give you the x value part. And if you put x into the equation and solve for y, you'll have the y value part of that vertex point. Okay, so that's another thing just to log back into memory. Remember, a, b, and c are the coefficients or the constants that are in your quadratic. A is always the coefficient of the x squared term, b is the coefficient of your x term, and then c is the constant that sits at the end. So finding a maximum or a minimum. Okay, a lot of times when you're doing things like throwing a ball or tossing something like that, you know how it's going to arc and get higher for a while and then it's going to drop. So the shape of that kind of a curve for this sort of problem ends up being a parabola. So those kinds of problems have functions that are quadratic. All right, so if you wanted to find the maximum of this baseball, think about the course of the baseball. It's going to do this. Well, its maximum is right here. Okay, what is that part of the curve called? Okay, hopefully you guys are thinking vertex right now, but if I can find my vertex, I'm going to be able to calculate the height of that ball. All right, so let's start going through this process. All right, so B is the coefficient of my x term, so in this case it's a 1. A is the coefficient of my x squared term, so negative 0.007. All right, so don't let the decimal throw you, just use it. If I were to find that x value of my vertex, I need negative b over 2a. So negative 1 over 2 times negative 0.007. Okay, punching that in and plugging that in, we get roughly 1 over 0.014, which rounded off is about 71.4-ish. Okay, now that's my x value. Using that x value and plugging it into the x's of my function will help me find my y value. Okay, so y is equal to negative 0.007 times 71.4 squared plus 71.4 plus 4. Okay, so roughly negative 35.7. Then finish calculating here. I don't know why my pen is squiggling on me, sorry. This comes to about 39.7 feet. Would be the height of the baseball at that vertex point. That's as high as the ball is going to get because after that point it's going to start dropping again. All right. There are a few that I would like you guys to do and hand in. Here they are. 22, 38, 44, 48, and 58. But practice with more, especially writing that standard form of a parabola. Okay, get back into the habit of how to complete the square and get that part factor to find your h and k.